Selamat sejahtera and good day. We are from Group 2 will present the Bernoullis Principles experiment. I am Nagalechumy Bathmanathan, metric number TG21003, will explain the objective, introduction and theory of the experiment. Objectives. Firstly, to determine the coefficient of the contraction that is available in the experiment. Next, to determine the jet velocity as volumetric rate of fluid exiting the orifice of a water in the beginning of the experiment. And to investigate the validity of the Bernoullis equation when it is applied to a steady flow of water through a tapered duct. Introduction. In fluid dynamics, Bernoullis theorem is the relationship between pressure, velocity and elevation in a moving fluid, which is liquid or gas, with negligible compressibility, and viscosity, which is internal friction, and a steady or laminar flow. Places of higher fluid speed will have less pressure than points of slower fluid speed in a horizontal flow of fluid. Bernoullis principle can be thought of as the fact that a fluid flowing from a high pressure zone to a low pressure region will accelerate due to the net force acting in the same direction. Theory. Bernoullis equation can be applied to a different types of fluid flows which result in various forms of the equation. The simplest form of Bernoullis equation is by using incompressible flow. Incompressible flows are liquids and gases with a low Mach number with the density of the fluid being constant, regardless of the pressure flow. Bernoullis performed most of his experiments on liquid and used the equation V²/2 plus GH P or density equals to constant, where V is speed of liquid, G denotes gravitational acceleration, H shows liquid's height over reference point, P is equals to the atmospheric pressure at the top of the container. V is considered as zero because the liquid surface drops in height slowly compared to the speed, which is jet velocity at which liquid leaves the tank. H is 0 and P is atmospheric pressure at opening H equals to 0. PGH plus atmospheric pressure over density equals to V²/2 plus atmospheric pressure over density. V² equals to 2GH. So the equation for the velocity will be derived as V equals to square root 2GH. To maintain a constant volume flow rate, incompressible fluids must accelerate when they approach a narrow restricted segment. As a result, a hose with a narrow nozzle allows water to flow faster. When water accelerates as it passes through a constriction, it gains kinetic energy. So for the next, my friend will explain the procedure for this experiment more detailedly. Thank you.
Assalamualaikum and very good evening. My name is Nurul Izzati binti Jusoh, TG21008. So today I'm going to present to you about the Bernoulli equation, which is I'm going to present to you about the material, precaution step, method, and result. All right. So here is the material that I'm using in this experiment, which is the following material are needed is an empty 1 liter 100 plus bottle, and then I'm going to use water mixed with the food coloring, and then I use sink to drain the water into. And then I'm using green cutter knife to make a hole. I'm using the ruler to measure the distance. And then I'm using stopwatch to measure the times. And then I'm using permanent marker to plot in the bottle. And then I use the tape to close the hole that I'm not using. All right. Here is the precaution step, which is please be careful when using a knife to make a hole in the bottle. It is the best to mark the part that you want to drill first. And then avoid experimenting in the location that human frequents to avoid slipping. And then use a bucket to drain the water into if you don't have the sink. All right? So let's play the video about the precaution step.
Before experiment. Alright, before start, I will use these two rulers to measure the bottle where I'm going to plot that I want to mark at the bottle. And then I will use the cutter to make a hole at this bottle. Next, please be careful when using this sharp cutter because it can cut your hand. Okay? When you like to make a hole in the bottle, you have to lock the knife so that the knife is not going to run from your hand or it's not going to get in. So you can use this one to lock and unlock. Alright? Now, I already make a hole in this bottle. Here the plot 1, 2, 3, 4 and 5. So we can start our experiment now.
Now, let's see about the method we are going to use in this experiment. First, make at least 5 holes in your bottle. And then, 2, record the height, which is height of every hole of the bottle. You may choose to attach the ruler to the side of the container or bottle or mark the increment on the container by using marker. And then, prepare the bottle for the measuring when the liquid is through at a different height. And then record the time taken of the water flow from beginning until stop. Since we already record the time, don't forget to record the distance S of the water flow from the opening. Now, let's watch about the experiment. First hole at point 20.9 centimeter. Now I'm using this stick to help me to measure the distance between the bottle and water. Time taken for this water to stop through from the hole is 43 seconds. Now we are going to see the second hole at point 18.9 centimeter. I'm still using the same stick to measure the distance between the bottle and water. So I'm going to speed the video. All right, for the time taken for this hole is taking 2 minutes 20 seconds. Now let's see the third hole at point 12.5 centimeter. You can see that the water takes time to go through and it took time 3 minutes and 9 seconds. And for the fourth hole, which is 8.5 centimeter, it will take time for 3 minutes and 11 seconds. Now the last hole at point 4.5 centimeter. I'm still using the same stick to help me. So the time taken for this hole, which is, let's check. The time taken for this hole is 4 minutes and 7 seconds. That's all for this experiment. Okay, Now you have seen the video of the experiment. Now let's see the result of this experiment. This is the result of the experiment, which is I already record for you the height of the water from hole, and we have time taken, and then we have distance between the water and bottle, which is S, and we also have jet velocity. For the first data, the height of the water from hole is 11.1 centimeter, which is take a time taken to the water to stop is 43 seconds. And then the distance between the water and the bottle is 21 centimeter. And the jet velocity is 14.76 centimeter per second. Second data for this experiment is height of the water from hole is 15.2 centimeter, which is take time for the water to stop from 0 until 2 minutes 20 seconds. And the distance between the water and bottle, which is S, from the opening, which is time equal to 0. So the distance recorded is 18 centimeter. And the jet velocity for this data is 70.27 centimeter per second. Now let's check the third data. The third data is height of the water from the hole is 19.5 centimeter, which is took 3 minutes and 9 seconds to water to stop through the hole. And the distance between the water and bottle is 20.5 centimeter. The jet velocity for this data is 19.56 centimeter per second. The fourth data that I have recorded for this experiment is the height of the water from hole is 23.5 centimeter, and the time taken for the water to stop through from the hole is 3 minutes and 11 seconds. And distance between the water and bottle, which is S, is 22 centimeter. And the jet velocity for the fourth data is 21.47 centimeter per second. And the last data that I have recorded for the experiment is the height of the water from hole is 27.5 centimeter, which is took time for the water to go through the hole is 4 minutes and 7 seconds. And the distance between the water and bottle, which is S, is 19 centimeter. And the jet velocity for this data is 23.23 centimeter per second. That's all from me. Now I'm going to pass to Zharif. Thank you.
Assalamualaikum. My name is Mohamad Aiman bin Mohamad Zaidi, TG 21007. For my part, I will present about how the data taken during the experiment. Firstly, we need to know what is data we need from this experiment. First, we need the distance of the water from the bottle. To get this measurement, we use ruler to measure the water from the bottle. Next is the time taken of the water flow out from the bottle. This data will be measured by using the stopwatch. For this slide, this is the data that we collect from the experiment. From this graph, we can see the time taken for the water to flow out from the bottle. This graph also shows the distance of the water flow out from the bottle over time. We can also see that the longest time taken for the water to flow out is whole 5, because it is the lowest height, that is 4.5 centimeter. It takes about 3 minutes 20 seconds to stop flowing out from the bottle. Next, this is the graph for water distance for each hole at t equals 0 seconds. From this graph, we can see that the water flow out from hole 5 at height of 4.5 centimeter is the long have the longest distance travel, and hole 1 at 20.9 centimeter has the shortest distance travel.
For the observation, this tree is the thing that we observe from the result of the experiment. First, lower hole has higher jet velocity. Second, greater depth in the bottle is under higher pressure, which force the liquid through a hole in the container at a greater speed. Number 3, each jet reach farther than any other jet at the point where it touched the envelope, which is at twice the depth of the jet source. What we can see from the picture, lowest hole has bigger distance than the tallest hole on the bottle. This happened because the deeper the depth of the water, the higher the pressure. So the jet velocity of the water will increase and the water will travel further from the bottle.
Hello, I'm Siti Nadira binti Saary, metric number TG21010. First, I'll explain about the discussion. Jet velocity is defined as the highest velocity signal obtained from release point of nozzle. Jet velocity, also defined as V, is water jet velocity in feet per second, and P is the pressure applied behind the nozzle in kpsi. For questions that have more than one equation, can be solved by simplified forms of the classic fluid mechanics equation that V equals to 0.98 times 2 times P over rho times 0.5, where rho is the density of water. Generally, all know that density of water is 1000 kg per meter cube for these equations, and P is in pascals. In thermophysics and thermodynamics, the heat capacity ratio, also known as the adiabatic index, the ratio of specific heats, or Laplace coefficient, is the ratio of the heat capacity at constant pressure to heat capacity at constant value. The gas constant is the constant of proportionality that relates the energy scale in physics to the temperature scale and the scale used for the amounts of substance. When a gas passes through the nozzle, its velocity increases on the expense of decrease of its pressure. Now, temperature change is directly proportional to pressure change, so its temperature decreases due to decrease of its pressure. For question number 1, discuss the relationship of jet velocity with time and height. The answer is the speed of the jet at the depth h from the total water column of height, say h, is just square root 2g h in the horizontal direction. This could be computed easily by applying the Bernoullis Law at the hole and at the top of the water. For question number 2, plot graph distance versus time. As you can see in the graph, for hole number 1, it takes between 40 seconds to 50 seconds for the water to exit. For hole 2, it takes between 2 minutes 20 seconds to 2 minutes 30 seconds, and for hole 3 it takes 2 minutes 10 seconds to 2 minutes 20 seconds. For hole 4 it takes 2 minutes 20 seconds to 2 minutes 30 seconds, and lastly for hole 5 it takes 3 minutes 20 seconds to 3 minutes 30 seconds. This is a more specific graph which you can see for hole 1 with 20.9 cm height takes 43 seconds for the water to stop, while hole 2 with 16.8 cm height takes 2 minutes and 20 seconds. Hole 3 with 12.5 cm height takes 3 minutes 9 seconds. Hole 4 with 8.5 cm height takes 3 minutes 11 seconds. And lastly for hole 5 with 4.5 cm height takes 4 minutes 7 seconds for the water to stop. And for the last question, determine jet velocity from the graph. Jet velocity is equal to distance of water from hole at the same time. From the graph, jet velocity can be determined by calculate the gradient of the slope from distance versus time graph. In conclusion, the purpose of this experiment is to prove the concept of Bernoullis Law. Bernoullis Law is the speed of a fluid relates to the pressure of the fluid. In this experiment, since there is no change in pressure, so the equation of speed V can be derived as V equals to square root 2gh. The speed of water exiting under the force of gravity out of the hole at the bottle is proportional jointly to the square root of the distance h between the water surface and the hole, and the square root of twice the acceleration caused by gravity g. Based on the results, higher distance of the surface of water from the hole, the higher jet velocity we got. In this experiment, the value of height from the water surface to the hole was calculated by subtract height of full water with height of water from ground. It is recommended to measure the value of height directly from the water surface to the hole to get more accurate value. And this is the reference. That's all from us. Thank you.